Today we will be discussing the estimation of stockpile volumes using drone survey technology. My name is Jay Rekla, and I was able to join Mr. Anthony Litzy from our Irvine office at the Battelle Chlorinated Conference in Denver, Colorado, where we presented the following information. Now in our presentation, we're going to discuss the equipment necessary, the necessary permissions to fly a drone at a project site, photogrammetry and what that is, airspace monitoring, programming the flight path in our photogrammetry software, the use of ground control points, what they are and why they're important, a few Federal Aviation Administration and LAANC regulations, the drone flight itself, and then stockpile volume calculations. All that with the objective of the post-processing of the data into 2D and 3-dimensional models for presentation to our clients. Now, before we begin, let's discuss a case study which was completed by Martin Remote Sensing, comparing the analysis of stockpiles which had previously been surveyed utilizing ground-based GPS survey equipment compared to that of an aerial survey. And what they found was that the ground-based survey, which took two surveyors 10 to 12 hours to complete, the drone survey was completed in just 4 hours. Survey point density of the aerial survey is far greater than that of the ground-based survey at 400 points per square meter versus 3.25 square meters per point, and the resultant variation of 0.6% is very accurate for our aerial survey. The benefits of an aerial survey are cost savings, obviously, the ability to cover a large area in a fraction amount of the time. We provide more information, including high definition photography and videography, including high resolution 2D and 3D models. And then the safety for removing workers from either an active construction site, steep slopes, or active stockpiles. Ninyo Moore selected the Phantom 4 Pro since it's one of the most affordable consumer drones on the market. The drone is very easy to fly for an experienced UAS pilot and includes safety features such as 5-direction proximity sensors for obstacle avoidance and a one-touch return to home function. The drone is capable of a top speed of 31 miles per hour, though for project site mapping, it's typically flown under 10 miles per hour. Before we fly a project site, it is of the utmost importance to have permission to be flying a drone at the site. We simply can't just show up to a project site, fly the drone, and then present that information to a client. We have, depending on the airspace, the agency or client that you're dealing with, you absolutely need to get permission to fly the drone. There hasn't been a project site that I've flown the drone for that either a curious onlooker or an adjacent property owner has asked me what I'm doing in the area and why the drone is flying. So it's always good to show those questioners the permission that you have to fly in the area. Our next step on the process is to have the necessary photogrammetry software used to fly the drone, capture and organize photos, generate their maps and inspection reports, and then easily share that with the entire project team. Now, photogrammetry is the science and technology of obtaining reliable information about physical objects through the process of recording, measuring, and interpreting photographic images and patterns. The more high-resolution photos we have and from different angles of the objects we're measuring, the better the 3D rendering of the model will be. Photogrammetry has been used for hundreds of years, and you can see some of the images here. You'll see them in our presentation later on, but this is the overlapping of photographs from different angles of our project site. This next slide shows the importance of being a licensed UAS pilot in order to access the national airspace system. Now, many people believe that cities or counties manage the airspace above their areas, but in fact, all airspace is regulated by the Federal Aviation Administration, or FAA. The FAA requires a drone pilot to be licensed in any flight which is for the furtherance of a business. Here we see our project site in the Los Angeles area, and this is called a sectional map. This is the first map a drone pilot's going to be looking for when you give them a location of a project site. This map's going to show us where controlled airspace is, and here we see controlled airspace for Torrance Airport and Long Beach Airport. But the map is going to show us where we can and cannot fly, and should our project site happen to fall within controlled airspace, we are able to gain permission to fly at these elevations shown on the sectional map. Now, Airspace is what we typically call an upside down cake, in that the higher the elevation, the greater the area of the tiers of the controlled airspace. Class B being the busiest airspace, Class C being very congested airspace, such as John Wayne Airport, and Class D airspace is for smaller airports with a control tower. Our project site happens to fall within Class G airspace or uncontrolled airspace. So to fly this site, I actually didn't need to get permission from air traffic control to fly. So long as the UAS pilot is flying within the regulations of Part 107, he could fly this without actually getting permission from air traffic control. Now, programming the flight in our photogrammetry software is very easy. For even an oddly shaped project site that you see here, it's a simple point and click to trace the outline of the area of interest that we're going to be flying. In the upper left-hand corner here, you see information changing as the map progresses. And this information is going to show the pilot how long the flight's going to take, the area, acreage, and how many images and batteries he or she will have to manage during the flight. Even when we do an enhanced 3D model, we'll do a cross pattern across the map. This information will change drastically, so it's vital information for the pilot to have before heading to the site. Ground control points, or GCPs, are defined as points on the surface of the Earth of a known location used to georeference our models. While not every map requires the use of GCPs, they are primarily used when projects require precision mapping. Even a marginal error of a few centimeters can decrease a map's global accuracy, so the use of GCPs is a must if accurate topography is your objective. To tag our GCPs in the field, we use the Emerald Reach RS Plus receivers, and here you see our base and rover receivers. And without getting too deep into the survey process, both are used to provide real-time kinematic corrections for our GCP locations. This is very accurate for X, Y, and Z coordinates to within centimeter of accuracy. Now, the placement of ground control points is very important. We typically place GCPs just inside the corner boundaries of our area of interest, including one centrally located target. GCPs are placed at the highest and lowest elevations achievable in the field. And while the placement of GCPs takes the longest amount of time, they very much increase the accuracy of our models, so we're sacrificing just a little bit of time for far greater accuracy of our maps. So now that we have the drone, the software, the flight is programmed, and our GCPs are located on site, now it's time to gain permission to access the National Airspace System through what's called the LAANC system, or Low Altitude Avoidance and Notification Capability. Here you see the drone pilot in the field ready to go. And with a few clicks on the iPad, the drone pilot notifies the FAA, who then notifies the nearest air traffic control center to grant permission for the flight. The LAANC system is going to notify us of any temporary flight restrictions or notice to airmen, which is basic information about the area we're flying, and the facility maps to let us know where we can and cannot fly. And it's the nearest air traffic control center that actually grants the permission to fly the site, should it be within controlled airspace. So with permission granted and everything's ready to go and everybody knows where we are and what we're doing, with a few clicks on the iPad, the drone will lift off and fly that map completely autonomously. There's zero input from the drone pilot. The drone pilot has to keep the drone within visual line of sight per FAA regulations, and that's in order to direct the drone away from any manned aircraft or wildlife should they enter our area of interest while we're mapping. Our UAS pilot in Phoenix, Brett McClellan, actually had his drone attacked by an American Eagle during one of his mapping sessions. So it's always good to keep the drone in visual line of sight and be able to switch the drone to manual flight to get it out of the way should that become necessary. So the drone will fly the map completely autonomously, and when a battery is exhausted, the drone flies home automatically with little input from the pilot to land safely. And if the map takes more than one battery, the pilot just simply changes the battery, hits the start button again, and the drone will lift off and take off back to where it left off in the air to complete the map. So this project site that we flew in the LA area was about 20 acres. It took one battery to fly, actually two batteries to fly. One was the autonomous flight and one was the manual flight for more different angles at a lower altitude, and I'll show you those here shortly. But once the drone map is flown, what I fly today can be processed overnight and be presented to you on your desktop the following morning, where stockpile volume calculations can begin. So in the program, the operator simply grabs the volume tool and draws a basic outline around the stockpile they want to measure the volume. So rather than driving 3.5 hours across LA, this can be done at your desk rather than traipsing across a dangerous stockpile. So the material can be viewed in 3 dimensions, where we categorize the materials, color code them, and then you can see the stockpile volume is known almost instantaneously. And then that can be viewed in 3 dimensions for further investigation. So even for highly congested areas of different varying stockpile materials, here we see concrete and asphalt, construction debris, gravel, boulders and cobbles, soil and dredge materials. Each one of them can be outlined and annotated, color coordinated, and categorized. And then we use the volumes for each one of these stockpiles to create our final product, which will be coming up here soon. But again, with the annotations left in place, we can view the entire site in 3 dimensions and get those lines as tight as possible to our stockpiles to increase the accuracy of our measurements. Another great tool that we have when we use the drone is what's called the Tiny Planet. For this method, the drone is flown to a particular area of interest where it sits and hovers and takes a series of 36 images, which are then stitched together into one panoramic image. That can be used to view the entire site, or you can zoom into an area of interest for further investigation, and you can see how great the detail is on our photographs here. This is my favorite slide. This is our geospatially located photography, where you can see the upper elevation of photographs, which is the map that was flown autonomously, with the lower elevation of photos, which were gathered manually during flight. So you can select any one of the images on this map, which then can be zoomed in upon for investigation. And you can see along here on the right side, the 2D and 3D images are right in line with each other, showing you just how accurate these maps are. You can then exit a photograph, select another area of interest, and select that photo to zoom in on a different area of your project site. Now, the 3D manipulation of this map in our photogrammetry software is fantastic. Basically, 50 people could do a site investigation without a single boot hitting the ground besides the drone operator. We can view the entire site in 3 dimensions and take measurements and volume calculations from the comfort of your own desk. Even a project site that's halfway across the country, this information can be shared with your entire project team and can be viewed from the safety of your desktop. So here we see taking a surface profile with a length measurement, and we can see the elevation for any area of interest along that line. These surface profiles can also be produced in a report, and those can be provided for geotechnical reports, environmental assessments, and so forth. So it really is a fantastic tool to have in our arsenal. And again, we can select that surface profile, that linear measurement, and view that profile in 3 dimensions as well. So this is just a orthomosaic photograph of the entire project site, but we can also overlay an elevation map. Here you see the red elevations being the highest elevations, where blue are the lowest elevations. And this, again, can be presented as a 2D model or 3D model to your client. So when the stockpile volume calculations are completed, this is one of the final products we presented to our client. Here you see all the number of piles. Some of the piles were measured in groups, others were measured individually. But we have a total of 98 areas with just under 2,800 cubic yards of material to be sampled across the site. In addition to our 3D models, we can also produce 2D topographical maps, as you see here. Again, red being the highest elevation and blue being the lowest elevations. Now, in 28 years of reading plans and specifications for proposal preparation, I was never presented anything as detailed as what we can produce with the drone. So these maps are a fantastic tool to have in our workload. And here we see the final product, which was produced to was presented to our client. We found a total of 550 individual stockpiles. Again, just under 2,800 cubic yards of material to be sampled across the site. These samples were tested for hydrocarbons, organics, Title 22 metals, chlorinated herbicides, pesticides, and PCBs for reuse or proper disposal. So the 2D maps and 3D models that we produce with the drone, those coordinates can then be given to our field staff using GPR equipment and GPS equipment to find the exact locations needed to sample. So if you have any questions or if you have any interest to use a drone on your project site, please contact Michelle Trevette at our Irvine office. She's at mtrevette@ninyomoore.com. Thank you for your time.